For part 4 of section 7.2, we are looking at the equations of lines, tangent lines, and normal lines. So a tangent line in general, so if you take a look at this parabola that you see here, a tangent line is just any line that connects or intersects that graph at a point. And so that would be a tangent line simply because they connect at a single point. One of the common mistakes for this unit is people see the word tangent and they associate that with a perpendicular slope. That is not the case. So anytime you're going to do a perpendicular slope, you're going to see this word here. This is the IB word for perpendicular, is the word normal. So if you're just finding the equation of a tangent line, that would just be the regular slope. If it's normal, then it is the perpendicular slope. So for the first example here, we are given a function. We are given a point, and we are asked to find the equation of the tangent line at this point that you see here. So what you've seen in the past for this is to find the equation of a line, we use the point slope formula. And that's the one that looks like this. So this one right here, this is the way you've probably seen it in the past. This is point slope, where you have a point and a slope. Your point is the x1 and the y1, and your slope is m. So in a case like this, I would plug 3 in for x1, I would plug 8 in for y1, and I would plug a 2 in for slope. Another way of looking at this formula is to divide these parentheses over to here. And so you would see it as y minus y1 over x minus x1 equals my slope. And that's just another way of writing it, and that's the way you're going to see it in the notes today. But you could do it either way. You're still going to come out with a proper answer once you format it correctly. So going back to this, if I am trying to do point slope, then I need a point and a slope. We already have the point. Here's my x1 and y1. I just need a slope. To always find a slope always means to use a derivative. So if I take the derivative of this function using the power rule that we just learned in the last lesson, then I'm going to get this look here. Here's my derivative. So to get the slope at a specific point, I just need a value for x. So in this case, my x value is 2. So if I sub in a 2 right there, then I'm going to get the slope, which is negative 10, at the point 2, negative 12. I now have a slope, I have a point, and so now I can go for the point slope setup that you see here. So this is one format of it. This is the formatting for the way I showed it on the other page a minute ago. So you're doing y minus y1 equals my slope times x minus x1. From there, formatting your answer, so this is really important. So I'm glad you're watching this video. You got to pay attention to the directions. If the directions do not tell you how to write your answer, this would be fine. You could leave it in this form. But in most cases, that's not going to be true. The directions on test will tell you a specific format for your answer. And if you don't follow those directions, you'll get points off. So if they specifically say to write your answer in the form of y equals mx plus b, then you got to get y by itself and put it in that format. If they say put it in the form of ax plus by plus c equals 0, that's another common one. So you would have to get everything onto one side and format it properly. So read your directions carefully on a test. Here's just another example really similar to that one where I'm given a point and I need a slope so that I can do the point slope format that you see right here. So again, if I were to find the derivative of this function using the power rule that we did in our last video, that's going to give you this for the derivative. And if I sub in the x coordinate, which is negative 1, for this x and for this x, then I'm going to get this look here. Anytime you sub in a number for a derivative, you come out with a slope or a gradient. And so the gradient at this point is negative 3. So now you have your point. Here's x1 and y1. Here's your gradient. So you just sub those into a point slope form and get your answer. Number 3 is just kind of more of the same, so if you want to give that one a try, this would be a good point to stop the video and give that one a try, but it's going to be real similar to the first two. So really key on this, you gotta read directions on tests carefully. If you see the word normal, that's the word for perpendicular. So really important that you notice that. This process wouldn't be any different, except that I'm finding the perpendicular slope, not the original slope. For all of these, remember you need a point and a slope. In this case, I don't have the entire point, I only know the x coordinate. So one of the first steps could be to find the y coordinate. So if I take -2 and plug that in for this guy and for this guy, then I can get the y coordinate. Remember that if you ever plug in an x into the original function, you get a y coordinate. If you ever plug x into a derivative, you get a slope. And so that's the two big different steps on this. Plug it into the original and you get a y coordinate of 3. So now you have the point. If I plug -2 into the derivative, so here's my derivative of this function, and if I plug -2 into that, I get the slope. So really important that I recognize on this problem, because I am looking for the normal or the perpendicular, that I use the opposite reciprocal slope in my problem. So this is the slope we would need to use, is 1/12. But now you can move forward with a point slope process. So here's your point, here's your slope. So here's the setup for that. Notice here's just one of the formats you can be asked to write your answer in. This is ax plus by equals c. That's a common thing to be asked of this on a test. So you got to make sure that you always read directions carefully on your test for how to write your answer. Here's another one that's kind of more of the same. In this case, we already have x and y, so I just need to come up with my slope. So I'm going to be plugging in 4 into my derivative. So here we go with the process for just finding the derivative. In this case, it probably would help you to put it back into radical form. Since you got to sub in a number here for x, this will be the easiest format for plugging a number back into. But if I stick a 4 in there for x into my derivative, it'll look like this. I come away with this as my slope. Because I am finding the normal, then I got to do the opposite reciprocal slope for my answer. So now I can go through with a point slope process with this as my slope in order to come out with my answer. And again, here's just one way of writing that answer, but just follow directions. For part B, this one's a little different because now they're telling you the slope. So we know the gradient is 13. Remember that the word gradient is synonymous with the word derivative. So when they say that the gradient is 13, that's the same thing as saying the derivative is 13, which means I'm going to set my derivative equal to 13 to solve for x. So in this case, here's the original function. If I take the derivative of that, I get 8x minus 3. I'm going to set that equal to 13 in order to figure out what my x coordinate is. So you got to be careful where this 13 goes. Really common mistake will be for people to put the 13 in for x, and that will just make everything wrong from that point on. So in this case, 13 is not an x coordinate, it is the slope. So that's why we set the whole thing equal to 13, solve for x. Remember, you always get a y value by plugging your x coordinate back into the original function to get a y value. So that's how you're going to come out with a y value of 11. But now you have your point. The gradient was given to us right here at 13. And so now you could either find the equation of the line or whatever they asked for. In this case, they just wanted point P. So we get to stop right here with an x and a y coordinate. Last one here, part C. Again, you got to highlight a word like this on a test, the word normal. So I know I'm looking at a perpendicular. I'm given a gradient, which remember is that would tell you that the derivative is equal to -1/9. In this case, I'm trying to come up with these two values here for a and c. Remember that if you're looking for two values, you probably need two equations to do that. And so the first equation that we can use is by just plugging these coordinates into the original function. So if I replace my x's with a 4, replace my y with 28, I'm going to get this look here. But I still have two unknowns. I can't solve yet because I still don't know a or c. But this is one equation that I have. You'll notice on this equation, one option would be to divide the entire thing by 4, just so that you get some easier numbers to work with. So that's an option. You wouldn't have to do that. Remember on this one also that they gave us a slope of -1/9, but because that is the normal, that must mean that the original is just +9/1. So here's my gradient is 9. So in this case, I'm going to set the derivative equal to 9 to get a second equation. So in this case, again, using the power rule, I have 2 times a, which is 2a. This would become x to the first. Right here, I have 1 times c, which is c. That would become x to the 0, so I just have the c right there. And I'm setting the whole thing equal to 9, since 9 is my gradient. that gives me a second equation. And so now I just need to solve my system of equations. So we used an elimination process on that one in order to work this one out. Sorry, before you got to that last step here, notice again that we replaced our x with 4. This 4 right here, just so we didn't have too many variables. But that's what gave you this look, and now we just used an elimination process in order to solve for a and c. Oh, I was going to mention, if you're still watching the video here, your calculator can actually find equations of tangent lines. So it's something you might want to look at just for some added help. I can either show it to you if you come on in and ask me, or you can throw it into a YouTube video. That's how I learned it, but your calculator can do some pretty cool things with derivatives if you look into it. So just an FYI.